Welcome to The Explainer. Today, we're going to break down two really powerful algorithmic strategies, the greedy approach and dynamic programming. If you're a computer engineering student, trust me, you absolutely need to know the difference. So just think about it for a second. Whenever you're facing some big, complex problem, how do you even begin to find the best possible solution? You're making choices like this all the time, right? The real question is, what's your strategy? Do you just grab the best thing you see right now? Or do you step back and meticulously plan ahead, weighing every single possibility? You can almost think of these two strategies as two different kinds of people. On one hand, you've got the impulsive optimist. This person lives for the moment, always grabbing what seems like the best immediate win. And on the other hand, there's the meticulous planner, who carefully considers all the smaller pieces to build a guaranteed perfect solution. Well, these two personalities, they're a perfect mirror for our two algorithmic approaches today. All right, so let's start with our impulsive optimist. In the world of algorithms, we call this the greedy strategy. And it's all about one thing, making the choice that looks the absolute best right here, right now. So the core idea here is really simple. At every single step of the problem, just pick the locally optimal choice. The hope, and that's a really key word here, is that this whole chain of locally best decisions will magically lead us to the globally best solution for the entire problem. It's fast, it feels intuitive, but it doesn't always get you the right answer. Now, for this whole optimistic approach to actually work out, the problem you're solving has to have two very special properties. First is the greedy choice property. This just means that making a choice that looks best locally is always part of some globally optimal solution. And second, it needs optimal substructure. That means an optimal solution to the whole big problem is built from optimal solutions to its smaller subproblems. If you got both, greedy is a fantastic and super efficient tool.
And a classic example where our optimist absolutely shines is the activity selection problem. So, imagine you've got a list of activities, right? Each one has a start and a finish time, and your goal is to cram in as many activities as you possibly can, but none of them can overlap. How would our optimist solve this?
The greedy strategy here is just beautifully simple. First thing you do, you sort all the activities by when they finish. Second, you just pick the very first activity on that sorted list. And third, you just walk down the list and grab the very next activity that starts after the one you just picked is finished. That's literally it. This whole strategy is incredibly efficient, usually running in what we call O(n) log n time, mostly because of that sorting step at the beginning.
So why on earth does this simple trick work? Well, the intuition is pretty cool. By always picking the activity that finishes earlier, you're freeing up your time as quickly as possible. This leaves the maximum amount of runway for more activities later on. This choice never locks you out of a better overall schedule, which, you guessed it, is a perfect example of that greedy choice property we just talked about.
But our impulsive optimist isn't always right. Sometimes that intense focus on the immediate reward can lead to a less than perfect outcome down the line. And this is exactly where the greedy strategy can get into some serious trouble. And here's the critical lesson you have to remember. A choice that looks amazing right now, in isolation, can have consequences you didn't see coming. It might completely block you from an even better combination of choices later on. This is exactly where our optimists can trip up. Okay, let's look at the classic 0/1 knapsack problem. You've got a bag, right? It has a limited weight capacity. And you have a bunch of items, each with its own weight and its own value. The rule is, you either take an entire item or you leave it behind. You can't take fractions. A greedy person might think, aha, I'll calculate the value per pound for each item and just start packing the most valuable stuff first. Seems logical, doesn't it? But watch what happens. If you greedily grab that item with the best value to weight ratio, it might be a really heavy item that pretty much fills up your whole bag. And in doing so, you might block yourself from picking 2 or 3 other smaller items that, when you add them up, would have given you a much higher total value. The greedy choice here, it actually hurts you in the long run. Our optimist has failed. So when the optimist fails, we need a new hero to step in. And this is where our meticulous planner comes onto the scene. In the world of algorithms, this is what we call dynamic programming, or DP for short. Dynamic programming is an absolute powerhouse. Its whole principle is to take a really complex problem and smash it into a bunch of simpler, overlapping subproblems. It solves each of these little subproblems exactly once, and then it stores their answers in memory.
This trick of storing results so you don't have to calculate them over and over, that's called memoization, and it's the key to making impossible problems totally solvable.
So the way DP usually thinks is by building a table. You start with the tiniest possible subproblems, like what's the best value I can get with a really small knapsack? And you methodically build your way up. You fill the table with answers to bigger and bigger subproblems using the results you've already stored. You're not just hoping for the best, you are exhaustively building the optimal solution from the ground up.
And this right here, this is the brain of the dynamic programming solution. For every single item we consider, and for every single possible weight capacity our knapsack could have, we ask a really simple question. What's the maximum value we can get? Is it better to not include the current item, or is it better to include it? By methodically making this one perfect choice for every possible subproblem, we build our way up to the guaranteed best overall answer.
So, there we have it. Our impulsive optimist and our meticulous planner. Let's put them side by side and really see how they stack up against each other.
This slide right here, this is your ultimate cheat sheet. Just look at the key differences. The greedy approach makes one local choice and never, ever looks back. DP, on the other hand, explores all the options for a subproblem before deciding. Greedy only works when a problem has that very special greedy choice property. DP works for any problem with overlapping subproblems and optimal substructure. And of course, that leads to a huge difference in performance. Greedy is often way faster, while DP is typically slower but much more powerful and guaranteed to be correct. So the really crucial takeaway here is this. One is not inherently better than the other. A greedy algorithm isn't just a bad DP algorithm. No, they are fundamentally different tools designed for completely different kinds of problems. A great programmer doesn't just know what the tools are, they know exactly when to use each one.
And that leaves us with one final question for you. The next time you're staring down a complex optimization challenge, just pause for a second and analyze its structure. Are you going to need the quick, intuitive leap of the greedy optimist, or are you going to need the exhaustive, guaranteed precision of the dynamic programming planner? Knowing which tool to pull out of your toolbox, that's what separates good programmers from great ones.